Hey grade 12s. So today we're going to look at a calculus question as well as a cheat sheet here. So we're just going to break down this question 8. So question 8, the graph of f of x equals negative x cubed plus 13x plus 12 is sketched below. A, B, and D is negative 1 and 0, are the x-intercepts of f. C is the y-intercept of f. Okay, cool. So this is our cheat sheet. We'll reference it as we move. But right now, question 8.1, it says write down the coordinates of C. So for a cubic polynomial, our last term, the actual term without an x cubed, x squared, which is not here, or an x, is our C value. It is our y-intercept. So right now, we have the coordinates of C. It is, in fact, 0 and 12, which we can interpret from the initial cubic polynomial. So then we move on to 8.2. And this is where our cheat sheet is going to come in. So we have to calculate the coordinates of A and B. So we know the coordinate of D, but we do not know the coordinate of A or B. So right now, we're at point 1 of our cheat sheet. We have to use our factor theorem or synthetic division in order to solve for these values. Right now, we've been given one actual value. So we have one of its roots. So I'm going to do synthetic division because it makes it a lot easier for me specifically. So right now we have our negative 1. Our negative 1 is our root. We then have to bring down the actual values in front of our x cubed, our x squared, cool, which we don't have in this case, which means that value is 0, our actual x value, and then the value without any x on it. Call this guy C. So right now, it means the actual value in front of my negative x cubed is minus 1. Our x squared has a value of 0 because there's no x squared in this case. And for the synthetic division, we cannot leave out any of the numbers in front. So what we then have to look at is our x. Our x has a positive 13, and then plus 12 is our last thing here. So with synthetic division, what we have to do is we just bring down this first term. So what we have for our first bracket is x plus 1. This is based on the fact that our root was negative 1. So if we were to solve for this value, making it equal 0, our actual x value is negative 1, like it is on our cubic polynomial. Okay, so that means we have a bracket based on the first root. What we then have to look at is trying to form the trinomial that's going to come down here, because this last value is trying to cancel, so we'll see it. So step 1 was to bring this negative 1 down. Whatever the value is for our cubed, we bring it right down. Okay. Step 2 is to multiply our root with this output value in order to see what we need to add to our squared. So minus 1 times minus 1 becomes positive 1. So what we then have to do, well, we have to add them down. So 0 plus 1 becomes positive 1. And then we have to, once again, times this root by this output here. So minus 1 times positive 1 gives us, once again, negative 1. Okay, so we times diagonally down and we add downwards. Okay, so we're at positive 13 minus 1, and that gives us, if we add these two, positive 12. Cool. And if we have done this correctly, when we multiply our negative 1 to our positive 12 at the end, minus 1 times positive 12 gives us negative 12. This last term, positive 12 minus 12, will come to 0, which is what we want. So at this stage, we're going to bring these down, and this is going to be our normal quadratic equation. So now we have our binomial and our trinomial that we are then going to have to factorize. At this stage, we can use our quadratic equation or just our normal solving. And then we will have 3 binomials. So that means our actual values, if we make them equal 0, because ultimately they all equal 0, we then have x equals negative 1, therefore x equals 4, and then x equals negative 3. So now we just have to place these values based on our coordinates A and B. So now we have our actual values based on synthetic division. Cool. So at this stage, we have solved the values of A and B. That is great. So we have the x-intercepts of this cubic polynomial. So then for question 8.3, we'll reference the cheat sheet in order to see what we have to do here. So it's saying determine the point of inflection of G. The point of inflection, the middle point here of G. If it is given that G of X, okay, this guy over here, G of X is going to be our new graph, is negative f of X. So that means we first have to distribute the negative into our cubic polynomial. So now that we have a negative to distribute into it, we're going to FOIL it in. So now that we have this cubic polynomial, we have the actual reflection of it. What is our cheat sheet telling us? Our cheat sheet tells us that the second derivative is required to get the point of inflection. We make the point of inflection equals 0. We then sub that x value back into the original cubic polynomial, or this reflection in this case, and then we get our y coordinate. Because we need a coordinate pair, we need the point of inflection, and that is a coordinate pair. So we're going to take our derivative using the shortcut method, distribute our 3 down, so we times our 3 down, and we minus 1 from our exponent. So we have 3x squared. So 3x squared, we have negative 13, x1 minus 1, we drop the x, and then we drop this whole minus 12 here. So that is our first derivative. Second derivative, we once again repeat from where we left off. Our 2 we times down to our 3, which becomes 6, and then we have which was minus 13 is now gone. So our point of inflection is then going to be our second derivative equaling 0. So 6x equals 0, we're going to divide by 6. 0 divided by 6 is 0, and then x equals 0. So at this stage, we have the x value for the point of inflection. It's telling us that x is 0 here. So we're then going to have to substitute our 0 back into our g of x. We are going to put our 0 back in here, and it's going to give us our y coordinate of our point of inflection. So we're left with minus 12, which means our point of inflection is 0 and minus 12. So we have then solved for 8.3, 4 marks. And then for 8.4, last question, we're going to calculate the values of x for which the tangent to f is parallel to the line y equals negative 14x plus c. So what are they asking? The keyword here is tangent. So if we go to our cheat sheet, we see gradient at a point is our first derivative. It is the gradient of a tangent. Sometimes in these questions, they're going to give us the coordinates that it passes through, and other times they're going to give us the actual gradient in this case, because they're telling us that it's parallel. They could say it's perpendicular, which means they multiply together to equal -1. But in this case, they are parallel, which means this other line has the same gradient. Okay, so that means we have to take our first derivative and make it equal -14. We're then going to solve for the x value, and that'll be all. So our first derivative of our initial f, because they were talking about f, so we are going to do our derivative equals the gradient at a point. So it equals -14. So at this stage, we're going to go like this, and we are going to solve for x to calculate the value or values of x for which the tangent to f is parallel to the line. So we're going to take that over. -27 equals -3x squared. Divide by -3. We have an x squared over here equals the square root of 9. And therefore, x's value is plus or minus 3. And that is our final answer for 8.4. Calculate the values of x for which the tangent to f is parallel to the line y equals -14x plus c. Otherwise, the cheat sheet is in the description below if you want to download it. And then let me know if there are any other questions coming up for exams, and I can help clarify it. And then I will see you in the next video.